Okay, welcome everybody to this month's Faculty Advisory Council's Forum. Our speaker today is Dr. Kate McClellan from the Faculty of Sciences here at Brigham Young University, Hawaii. She's in the Exercise Science program, and I'll introduce her more in just a moment. We're going to start off though with a prayer, and Ann Springer is going to offer that prayer for us, who also happens to be Dr. McClellan's #1 fan. I've been told. Thanks, Kate. Thanks, Ann.
Our Father in heaven, we're so grateful to thee this day that we can gather together as faculty and students and as our ohana, and to hear from Dr. McClellan, to have her share with us the things that she has learned and her insight and her specific expertise. We're so grateful for her and the hard work and effort she puts forth into her research and into her teaching of her students. We're so grateful that she's here with us on this campus and that we have this opportunity today to hear from her. Please bless her to be able to fill the spirit as she presents, to be able to share the message that she's prepared in the manner in which that she desires. And we're grateful as listeners and observers for the opportunity that we have to continue learning as well as teachers and as students, to come together and to learn as a group. And we're grateful for these things and ask for these blessings in the name of Jesus Christ. Amen.
Amen. Thank you, Ann. So a couple quick announcements and just sort of ground rules for our Zoom forum today. So if I believe everybody is muted, you have the power to unmute yourself, but please exercise that carefully. So yeah, please just take a moment, make sure you are muted, and be sure we're not hearing kind of your side conversations during Dr. McClellan's presentation. We thank you for that. And we will have another faculty forum. I'm not sure if there is one lined up for December, but we will get an announcement out for that really soon. So today's speaker, as I mentioned, is Dr. Kate McClellan. So just to introduce her a little bit, she is, as I mentioned, an assistant professor in the Faculty of Sciences here at BYU-Hawaii, where she teaches in the Exercise Science program. So she actually got her degree from BYU-Hawaii just very, very recently, I'm sure. I don't have the year and I won't share it, but she got her BS here from BYU-Hawaii. She then, a few years after that, went on to do a PhD in rehabilitation science at Loma Linda University, where her research focused on the impact of multiple stressors, sort of the compounding impact, from what I understand, of multiple stressors on endothelial dysfunction in aging and diabetes. I actually tried to remove endothelial dysfunction from that description because I didn't want to over jargon people, but she said, nope, that's my jam. You better put it back in. So I will. I'll let her explain what that is, I'm sure. So before joining the Exercise and Sports Science program at BYU-Hawaii in 2018, she worked as a clinical research and project manager for a number of different companies, and was and still is, I'm told, the president and CEO of the KM Clinical Research Group, where she continues to consult on clinical research with a number of different projects. We're really excited to have Dr. McClellan share with us today her research, and the title of her talk is A Macro Look at the Microbiome, something I'm very interested in hearing more about. And so I'll turn the time over to you. Go ahead.
Awesome, thank you. Okay, let me share this. So I'm having to borrow someone's computer. So normally I'm very tech savvy. And it's very easy for me to orient things around. So here we go. Okay. I am going to pin my video so I can see me. Okay, so a macro look at the microbiome. I wanted to talk about, this isn't research that I'm specifically doing currently. It's more of like a passion study that I have, like this passion side gig that I have. I love the brain, and everything in the brain is just, it's what I It's what I love. It's what I do. And I've done a lot of research with the brain, which is really cool because it makes like a lot of other body systems more understandable because it all really ties back to the brain. So one area that I've looked at a lot in the last year with actual research is right here in this prefrontal cortex, this frontal lobe here. And it's for higher mental functions. So it helps with planning and concentration, and just like executive function is really what it's called. So last year I got to go to a big conference in the Journal of the Society of Neuroscience in Chicago, and hold a cadaver brain, a real cadaver brain. And when funny story, when I was in grad school, I dated a guy because he was in the dental program and they had better cadavers in his program than I had in mine. And so I dated him for the cadavers, but they were really good cadavers. And so I just really like the brain. So I've always just been passionate about the brain. So anyway, so I got a hold of real brain and I got really, really excited about it. And currently a lot of research that I'm doing for KM Clinical and what I've been doing for the last really like 10 years is the brain, but a lot with the spinal cord. That is a huge area of like sub expertise that I have found myself in just the industry of medical device and implantables and rehab and things like that. Is anything related to the spinal cord is totally my jam. And I love it. It's so amazing how the nervous system works. So what I've done with students is, backtrack. So the brain is important because it receives a ton of blood from the heart. It's just a huge organ in terms of metabolic demand and oxygen consumption and glucose consumption and just fuel. And it's just a huge consumer of things, just of everything really. And a piece of device that we got, a research equipment that we got recently for the EXS, and I know psychology has one as well, as an FNIR, a functional near infrared imaging. And this gives us the ability to non-invasively and monitor blood flow changes in the brain. So it's just this headband that you wear here, which is kind of cool. And you can see blood flow changes it's really just the prefrontal cortex because it's this headband here. So you're not going to see anything that the headband isn't on. You're just going to see where it's at. But it can send in a light and it can detect the blood flow changes, the oxygenation of the hemoglobin in that area of the brain. And areas of the brain that are being activated have changes in that oxygenation, have changes in that glucose uptake, which is going to, spawn metabolics to be released, specifically CO2, which is going to cause vasodilation and all this nerd language. So, but we can see activity in the brain without having to do an MRI or a CT scan or anything that would be very expensive or have a lot of radiation involved with it. It's really just light diodes. Like if you get like a pulse oximeter on your finger, it's that kind of thing, but on your forehead. So it's really easy to do. So we did a lot of research with it because I had students that needed to do research as part of their senior projects. It's a requirement for EXS. And so we had a bunch of different groups and they wanted to look at upper body workout with breath hold. So when people are surfing, they'll paddle out and they'll have to like paddle under the waves and they get out there and they're kind of winded for a minute and they're kind of like, surfers are like, yeah, as soon as I paddle out, I just kind of have to take a minute because I just feel foggy. And so we wanted to see if that was due to changes in the brain, like if there was blood flow changes associated with upper body workout with breath holds surfing. So we had people, this is one of the research posters that we had them paddle back and forth in the pool a whole bunch. And every time they got to the end of the pool, they had to like get off the board and go under the water and come back up and then paddle across. So it was kind of as close as we could to mimicking paddling out in waves. So anyway, we also looked at high versus low intensity exercise, which was cool to see if there was a difference. And there wasn't really a big difference, but we had a really small sample size with this. Remember, this was being done in February, March, and COVID kind of stopped a lot of our studies before we were able to get a large enough sample size for some things. We also looked at pregnancy changes by trimester. So this was women when they were pregnant, wanted to see if there was a difference with those that worked out during their pregnancy, before and during their pregnancy, versus those that didn't, and if their cognitive function changed and if their blood flow oxygenation changed, because everyone complains about pregnancy brain. Well, not guys, but mostly girls complain about pregnancy brain. And so we wanted to see if we could detect that, if that was something that the FNIR could detect and what kind of data we were seeing from that. And then something else that we're looking at was sleep patterns and changes in cognitive and executive function. So having just like one bad night's sleep can kind of set you back for like a day or so. And we wanted to see what that looked like with prefrontal cortex oxygenation changes. So really cool stuff. And we don't really have any good data to present on that because, again, we were cut short. But future research that we want to be looking at is differences in exercise. So exercise science, we like to look at exercise and people moving, and there's a lot of good changes that we see with exercise and the brain. And we wanted to see if we could see that with FNIR, and if there's any certain exercise, like types of exercise that are more beneficial to improving cognition and executive function than other ones. So resistance versus cardio, upper versus lower body, doing a preferred versus a non-preferred exercise. Do you have to concentrate more when you're doing something that you don't like versus if you do like it, like that kind of thing. And then we also wanted to look at like within expert versus novice with things. So if you're doing a task that you like and that you're really good at, does the oxygenation in your brain change? Does the activation in the prefrontal cortex with executive function and like judgment and concentration and stuff, does that change if you're doing something that you're really good at versus something that you're not very good at, or something that you prefer versus not prefer? So like, for example, we're going to take music majors or music professors and have them play their favorite music or sing their favorite music, and then either do something completely unrelated or play something that they don't enjoy, or play a different instrument that they're not as well versed at, that they're more of a novice at, and see if there's a change there. But then also like doing the activity versus watching the activity, is there a change? So anyway, really cool things. And then lastly, with health and weight changes, we wanted to see if there's a difference between as people were changing their body composition with their fat and muscle composition. Is there a change? We've seen differences in obesity. So as people change their body composition and go from a normative body mass to an overweight to an obese body mass, we've seen changes in the brain that way as far as cognitive function. And so we wanted to see, as people were losing weight or changing their body composition, was there kind of a set point where once you get to that point, then you're going to notice improvements, or is it just a slow, gradual change? How much does obesity and the increase of adipose tissue affect cognitive function in the brain? And so is there like a happy point that you want to get to, like, ooh, you really don't want to get above 20% or 25% body mass or something like that, because that's when you're going to start to notice a cognitive function. So that would be something that we want to look at in the future. So, but it's all very cool, but it leads me back to the brain. So back to the brain, it's very connected. The brain itself is very connected, and it has these tracks, and everything is on these pathways. And it's not just one organ working by itself. It's connected to the whole body. And the whole body has these pathways, this nervous system that goes up and down in every which way. And when you overlay that with the organs, it makes for like the whole human body. But what we know is the human body isn't just that. It's throughout time and ages and centuries and cultures, we've had this idea that the body is more than just flesh and bone. It's more than just nerves and organs and things like that. There's something more holistic. And so most practices, other than like strict Western medicine, have incorporated some other element, some energy, some healing, that's something outside of just this is the symptom and this is the solution. It's something that there's more inclusion in how to solve the problem. And so there's a ton of different types of medicine and healing and ways to restore homeostasis. And some of them are great and some of them are less effective, but all of these are used by some people and they're practiced almost like a religion. And we know there's a lot of good things in everything. Like there's good in a lot of things. And so what most other cultures and civilizations and countries all have in common with their healthcare and healing and wellness is some sort of herbal medicine. And I wanted to kind of look at why was that the easiest, like the lowest common denominator that they all kind of had in common. And I found that, like, my question was, what was the common thread? Why did they all kind of go to herbs and roots and tinctures and things like that, other than it's just readily available? And what it brought me to was the microbiome, this huge organism that is in and around us. And when you look at it, it's not just like you, but it's cells on you. It's in you. It's so much of you is your microbiome. And so it does everything. It just literally, it does everything. There's 10 times more of them than there are of you. And we'll see that in a bit. It's 90% of diseases can be traced back in some way to the microbiome. Most of us differ in our microbiome drastically, even between partners, cohabitating partners. They may have similar diets and they're going to be in similar environments, but their microbiome can be off by 80-90% from their shared domestic partner. So they looked at cohabitating partners. And this microbiome is huge. So they recently did a study. They found they were able to sequence not just the DNA of bacteria, but the RNA. So they're able to really see not just what do they look like, but what proteins and metabolic processes are they involved in. And this recent study, more than what they could find in like culturing cells in the lab, they found over 1,000 new strains of bacteria, new types of bacteria. So that's what's all here in purple, is all these brand new bacteria. So this is the tree of life. If you talk to like a microbiologist, they're like, oh, the tree of life. And we're like, yeah, Nephi. And they're like, no, it's this. And this one study came out with almost 1,100 new bacterial strains. So in our environment, we have this tree of life that's in and around a lot of us, but we also have fungi and viruses. And right now in this day and age of COVID and everything is deadly and it's all going to kill you eventually, there's also a lot of really good things. So our microbiome is 10 times what we are. So that we have 10 trillion human cells. There's 100 trillion microbial cells in and around our bodies. So there is a very large influence in our lives, more so than people have realized and science has realized in the past. So as research is going forward, we need to figure out, like, what does this mean? What does it influence? Why do we care? And how much should we care, right? So it influences everything: our sleep, our mood, our making vitamins. So there's some vitamins that our body can make internally, which is great. And there's some that we have to intake into our diet because our body can't make it. And that's all kind of regulated by our microbiome, with the ones that we can make internally. Our fatigue, our skin, our acne and eczema and psoriasis, those skin disorders, generally skin manifestations are skin disorders are a manifestation of an internal imbalance, generally. Joint pains and things like that. So it's in a lot, our microbiome. And what we found was I feel like I'm part of a team, but this is like my passion project, and I do a lot of interfacing with this kind of research. But what we found was it changes over time, which is good. And it's different for healthy versus non-healthy people, and obese versus non-obese people. So babies that are breastfed versus formula fed have different microbiomes, different combinations of bacteria in their microbiome. And then when they change to solid food, that changes again. In children, malnourished children versus ones that get a lot of antibiotics for whatever reason, their microbiome is different than someone that's healthy. And then in adults, healthy versus obese adults have different microbiomes. And then as you age even further, that's going to change additionally. So there's this evolution of our microbiome, and that is something that's really important. Also with our microbiome, it's not just like all the same everywhere. It's not just your gut. Like people think, oh, that's in your digestive system. Great. No, there's sites all over your body that have different types of shared characteristics. So your the fecal biome is different than the cell cultures that you would get from your skin, than women in the vagina and infants with their fecal microbiome. What this diagram here is, it's supposed to be, I didn't screen record it, but it's an example of a baby when the baby was about 6 months old. It got a really bad infection. It had to go on an antibiotic, and it started with the baby's microbiome started similar to the mother's vaginal microbiome, because it was birthed through the vaginal canal. And through the course of the antibiotic treatment, it dropped and it lost all of that diversity, that biodiversity, into what was just a fecal microbiome. And then it slowly rebounded back, and then it got another infection and it dropped again, but it slowly came back. And so that's these pathways here, is this kind of progression of changes in the microbiome of this baby as it had antibiotics, and then it recovered, and then it got sick again, and it recovered again. So what we saw was that even babies can recover their microbiome after a round of antibiotics, which is good, because some people are like, oh my gosh, never give a kid antibiotics. You're going to kill their microbes for life. And it's like, yeah, don't like give them out like Tic Tacs, but also they're not going to die. It's not going to be like the end of the world for them, because we've lived past our first year infection. So microbiomes are important also because our social environment is going to influence our microbiome. So who you are around, who you hang out with. We're seeing that now with COVID, with just the easy transmission of viruses from human to human and from human to surface to human and things like that, that what you're around influences your skin and your mouth biomes. And so that's cool. It's just something also to take into consideration. So what happens when things go wrong? That's what we really care about, right? Like, what happens when things go wrong? So you get everything, like literally every like 90% of diseases are associated with a perturbation in cultures. And so in an imbalance in your microbiome. So something in your gut, skin, whole biome cloud, as they refer to it, something in there has gone awry, and you don't have the biodiversity that you used to have. You're not as, you have more of the bad bacteria and less of the good bacteria, and it is linked to depression, autism, oral health, cancer, COPD, asthma, obesity, diabetes, infections. IBD is irritable bowel disease. And we found that even the health of the microbiome can impact how your body responds to drugs. So this is the cells and the lining of the small intestine. And this would be like the liver. So some drugs, it'll be fine, it'll be active. Some drugs are completely blocked from being absorbed. Some drugs become toxic. Some drugs become inactive. Some drugs are inhibited. They're not even able, they're kind of blocked. We don't really know what happens, but some of them are inhibited, and the liver doesn't get to metabolize them as quickly, or it metabolizes it a lot quicker. So the quality of drug response that your body elicits, that it responds to, is impacted by your microbiome, as well as what's even really going to work, right? Which is kind of cool. So we're seeing these changes. And so that's the next level of research in pharmaceuticals is, yeah, how do our drugs work, which is great, but what happens if it's given to someone with an unhealthy microbiome or with a very biodiverse microbiome? Is it going to happen? Is it going to work too fast? Is it going to be dose dependent and too toxic? Or is it not going to be effective enough because too much of it is going to be metabolized by an unhealthy microbiome? So that might be something that has to be like a pre-screening before a doctor prescribes something, is like, well, we can see by your microbiome that you have an imbalance of these. So you may need to do like a round of probiotics before we give you this, right? Something like that. We've seen links with your microbiome with dementia, Parkinson's disease, and multiple sclerosis. I can never say that word and I will die trying, but multiple sclerosis, MS. For some reason, all my references are supposed to be down here. They all got bumped off. But if you want, I can send you the slides for this, and all of the references are in the slides as well. So all of these patients that you think it's it's all in your head. It's all in your head. It's not, it's all in your entire body. That changing someone's microbiome will change the severity of their symptoms. They found that especially with autism, and that one hits personal because I have a daughter with autism and it's her birthday today. Happy birthday, Kyla. She's 6 years old, and heaven help us if we can keep up with her. But what they found was that if they did a really cool study on children with autism, and what they found was they predominantly have an unbalanced microbiome. And if they could balance their microbiome and increase the amount of healthy microbes in their gut specifically, they could reduce the severity of their symptoms. But one of the problems with autism is they're very food sensitive, very texture sensitive. And so a lot of times they have that unhealthy microbiome because they don't like to eat a variety of foods. My daughter hates fruits and vegetables. I've never met a kid that hates fruits and vegetables more than my adorable daughter. But there is no amount of bribery that can get her to eat a baby carrot. And baby carrots, I mean, they're not that bad, right? You dip them in ranch dressing and they're delicious. So, but what they found is that if they could supplement the microbiome, if they could augment it, that the severity of the symptoms decreased, and it stayed decreased even 2 years later. It wasn't just a one and done, like an acute effect. It was a chronic change. So they're finding that if you can change the microbiome, and I don't know why this got bumped off, but they found that if you can change the microbiome and just kind of jumpstart it, it'll have long-term effects, long-term benefits, which is really cool. So blood-brain barrier was altered, intestinal permeability was altered. All these things are altered by having a bad microbiome. So let me skip ahead. They found it also with HIV response. So I have another daughter. She is helping with HIV education and awareness and research and everything like that, she will eventually be working in South Africa with the research there with the Reagan Institute. And what they're working on is helping see how this microbiome and the young Black women there, how they can help them essentially not get HIV and AIDS, because it's very rampant down there. And what they found was that those that, regardless of their sexual activity, those that had an unhealthy vaginal microbiome were more likely to get HIV than those that had a healthier microbiome in their, specifically in their vaginal flora. So COVID-19, we're seeing a really strong link between those that get COVID and the severity of their symptoms and their microbiome. It's really quite amazing. So, and even they can test sewage water and they can find hot spots of outbreaks in the community a week before physical symptoms occur. So before you even start feeling sick, it's in your body and you're excreting it, and it's in the wastewater. And so public health officials are starting to test sewage to see where these hot spots are, so they can start isolating those sections of the community, not just an entire community, but like maybe these 3 streets need to have a special focal testing to see who is maybe an asymptomatic carrier or symptomatic, or positive, but not symptomatic yet. So this is what you want to know. How do we improve the biodiversity and health of our microbiome? That's why you're all here. So the number one is fecal transplants, but nobody wants to do that. Nobody wants to get a poop enema. That is disgusting. And nobody wants to swallow it. It's not even any better. That's not the milkshake that you want. So if you had to choose, everyone's going to check no. But we have found that exercise can be very beneficial. And it doesn't even have to be like crazy, insane CrossFit exercise. It can just be a brisk walk. It helps improve brain-derived neural function. So it helps with the increase in neuroplasticity, in blood-brain barrier efficacy, keeping bad things out and good things in, things like that, preventing a lot of cancers. Because this one common thing that they found in diets is this compound called butyrate. And they found that with dietary fibers, specifically in whole and plant foods, it acts as like a fertilizer to good bacteria. It's not a probiotic, it's a prebiotic. And prebiotics are like totally the thing right now, which is good, because this butyrate, we found that if you have higher levels of it, you can decrease the severity of the symptoms of a lot of really impactful diseases, because the way that this butyrate works on different parts of a cell or in different activities within a cell, it can improve things. So high fiber diets have found to decrease the severity and risk of diabetes, cancers, obesity, stroke and cardiovascular disease, which is a huge killer in every country, because improving the blood-brain barrier, because it helps with these short-chain fatty acids, specifically butyrate. So another one that we found was helping with the cognitive control in kids. So getting kids on a decent diet of more plant fibers can help with multitasking, working memory, maintaining focus, which is really hard to do when they're all online, but that is helpful. So what does a decent diet look like? Let me go to, we like this one, this. So this is my last one. So this is what I'm gonna leave you on right here, because this is what you guys care about. This is, unfortunately, it's a little bit pixelated, pretend it's not. But it's basically like the Mediterranean diet. So if you were to have like the perfect diet, you would want lean proteins, you would want awesome prebiotics that are going to have the quality fibers in them that the bacteria are going to feed off of. You can have probiotics. Taking them the capsule kind is a little bit less effective than taking it in the natural form. So things that are pickled or fermented, kefir is real good. Kombucha, if you don't mind the taste of it, sauerkraut. What's interesting is in a lot of cultures, their diet naturally includes something pickled, like kimchi in Korean diet, and kombucha and kefir in Middle Eastern and Indian. It's just, they naturally have something in their diet that is a probiotic. Whether or not that's why they have it, they're like, oh, this is good for gut health, but it's just something that's naturally there. So obviously fruits and vegetables, the more the merrier. And the key here, and I know I'm talking so fast, the key here is it's not about getting 10 servings of kale a week. That's not going to increase your biodiversity of your microbiome. It's about getting 10 servings of 10 different things. You want your microbiome, you want your diet to look like an English garden, not an Arizona backyard. So you want your diet to be the rainbow. You want everything to be in your diet. It's better to have one serving of kale and one serving of bok choy and one serving of spinach and one serving of Swiss chard than 10 servings of Swiss chard and calling it good. That's not going to increase your biodiversity because your body doesn't have to respond. The biome is reactive, not proactive. It's not going to make what it doesn't need. So if you're eating a bunch of different things to maybe just getting like one apple and one orange and one kumquat and one pomegranate, that's better than eating a whole watermelon all in 1 week and assuming that that's going to increase your biodiversity. So this is, again, I'm not kidding. This is what I'll leave you on. Are there any questions? Are there any questions? I know that was a lot. Okay. I can't.
And just to point out, people can drop questions in.
Yeah, jump into chat. Thank you, Brother Bell. Jump into chat or you can unmute. Yeah, I will definitely share my slides. I formatted them and I think I just formatted it too big because I had them in there. So I'll redo it. And I have all of my references in my notes for each of these slides. So you can go and you can see the article and you can see where I'm getting this data. And I probably pulled 40 or 50 articles for this presentation because I'm evidence-based. I feel nutrition advice should be evidence-based. If we're talking about our bodies, it should be evidence-based. I don't care about your opinions. We all have different ideas, but I feel like if I'm going to give you something to do, I feel like it should be the best quality knowledge. So everything that I've said here is evidence-based, just know that. And ideally, I tried to pull articles that were human models, not animal models, because we don't know exactly the difference between what happens in a mouse and what happens in a human. That doesn't translate 100%. So some of the things are only in animal models because humans aren't too keen on getting their brain cut into. But I tried to find as many animal model papers to cite for my evidence versus like what happens in Petri dish because nobody cares. So You guys are so supportive. I love it. Any other questions? You guys are the best.
So it looks like there was one. Brindy had one. When you say 90% of disease can be traced back to the microbiome, does that include chronic disease?
Yes, it does. Absolutely, it involves chronic disease, because if you chronically have a disproportionately diverse, if you have a very homogeneous microbiome, your body's going to respond in kind. It's going to have a harder time battling a bunch of different invaders, viruses, bacteria, things like that, because it doesn't have the bacteria and the metabolites of those bacteria to help influence positive cell reactions, and positively influence the immune system and the immune response and things like that, and inflammatories and cytokines and things like that. So yeah, I mean, and all this, like COPD is chronic, and multiple sclerosis is chronic, and autism is chronic, and like Parkinson's disease is, you have it until you die, chronic. So yeah, acute diseases, the severity, the likelihood of getting it and the severity of your symptoms can be impacted by your microbiome, but the symptomology and the severity of chronic diseases is really a little bit more important, because that's more likely to increase your mortality, your risk of mortality, your likelihood of death or early death. And so that's why a lot of the research is being done in these chronic diseases on how can we maybe not have to give them so many medications to control or alleviate the symptomology of this disease? How can we augment their life in another way to let their body take over as healer, rather than this chemical that might not be doing as good of a job as something else? And what they found is that the microbiome is really involved in like literally everything. And so if we can do other things where we augment the microbiome, the health of the microbiome, that might take the place of other interventions. Might. Let me just emphasize that really poignantly. I'm not saying don't get off your meds and start eating broccoli. That's not how it works yet.
There was an earlier question, but I wanted to highlight a question that Anne actually asked. She said, because it relates to what you were just saying. She said, in your opinion, why don't more health professionals share evidence-based nutritional advice instead of prescribing medicine to mask symptoms?
A lot. Okay, so to Western-based medicine's credit, a lot of the models that we've seen with microbiome has been done in animals, and it's really unethical to say that what happens in a mouse is what's going to happen in a human, because you don't know. And even what happens in a chimp or a primate is what's going to happen in a human. So to say blanket statement, yeah, why don't you just eat more bell peppers because they're so colorful and then you won't have diabetes anymore, is almost unethical. When they know that there's certain medications that will work. And while those medications are working, what if we also start augmenting your nutrition? But I feel like a lot of practitioners aren't utilizing the impact of nutrition quite yet, because one, they're not getting a lot of it in med school. They're not getting it even in their DO, their doctor of osteopathy. They're not getting a lot of that education in their curriculum. And they might not be well-versed on the knowledge. Like really, it's so much to know that it's like a whole side hustle to be up to date on all the nutritional knowledge and the microbiome and what it's doing. But if that's your world, obviously you're going to be really well-versed at it because that's your thing, but you're probably also not cutting into people and reassembling hips and femurs and spinal cords at the same time. You're probably just like, a silo of knowledge. So it's going to be happening more as we get more human models that are responding well to nutritional changes, and the symptomology and the severity of their diseases is being reduced. And we're seeing the changes with COVID and with the AIDS in the South African women and things like that. Like as more correlational studies are coming out that are, having a strong relationship, even causal relationship, then medical practitioners would feel more comfortable ethically saying, okay, you should also be doing this. They should be just saying, you should eat healthy, but sometimes they don't. And I can't speak for all of them. I work with really good ones, but I can't speak for all of them.
Awesome. Another question from Josephine about, she says, yes, can this be done with a plant-based diet or vegetarian? I guess she's probably referring there to just improving your microbiome.
So that's interesting. So one of the keynotes that I saw, he talked about, yeah, so you need to have a lot of plants in your diet. But, and there's a lot of studies that are coming out that said there's a lot of high risk of cardiovascular disease in people that consume a lot of meat, specifically red meat and dairy. And what they found was yes and no. So if you're eating lean meat, so the Mediterranean diet with the lean meats, low fat meats, whole meats, not processed meats and fishes, and even like beef and chicken and turkey and tuna and sardines and things like that. If you're eating a lot of those unprocessed, more whole protein sources, your risk of cardiovascular disease doesn't go up, it actually goes down. So your risk, your all-cause death will go down if you're eating those whole unprocessed protein sources. And that includes legumes and tofu and things like that. But if you're eating the pure protein, like animal protein, it's the inclusion of processed meats that's going to be increasing your cardiovascular risk and those negative heart effects. But then also if you're eating protein in place of vegetables and fruits. So if you're increasing your protein intake, but you're decreasing your plant intake for the sake of that protein, that's going to be causing a big imbalance and an increase in cardiovascular disease. But eat meat sparingly. If you can include whole unprocessed protein in your diet and include plants and be balanced in that, your risk of death decreases more so than just being straight plant-based and no protein. So being protein deficient causes more problems than including a little bit of quality protein and keeping your plant amount high.
Perfect. Question about fecal microbial plant transplants, which
don't do it, it's gross.
I know you kind of wrote that off and said nobody would be willing, but it looks like we have somebody who might be interested. It says, fecal microbial transplants, do you recommend? If so, is there an over-the-counter product? I guess how does one go about it?
There's not an over-the-counter product. How it works is someone with a healthy microbiome is a donor. And so they will poop in a cup, basically. And what they do is they spin that and they make it into it's super gross. They make it into a slurry. And then they do a colonoscopy on the recipient, and with the colonoscopy, they'll deposit that fecal matter from the donor into the colon of the recipient. And so it's a fecal transplant. They're taking fecal matter from one healthy human and putting it into the colon of an unhealthy human. But in 90% of people with chronic C. diff, which is a terrible digestive disease in response to generally a high dose treatment of antibiotics over time, these people will get C. diff and it can last for years. And there was nothing they could do to get rid of it. It would just it's terrible. It's like irritable bowel disease, but worse. If they found that if they did this fecal transplant, in 90% of the patients, it went away for forever. It never came back. And they found they could do that with kids with autism and these other diseases. They could do these fecal transplants, and it dramatically reduced the severity of their symptoms of these diseases. And some of the diseases, it got rid of them completely. So it's awesome and it's great. You need to do it in a hospital setting. Don't just shovel something out of the toilet and stick it in an enema tube and hope for the best. It doesn't work like that. Things will go poorly for you. And there is nothing over the counter because you need to make sure that the donor is truly healthy and not going to be putting something negative into the capsules or the product that would be more harmful than what you already have in your biome. So it needs to be medically monitored.
Awesome. Okay, another question kind of related to gut health. Can a leaky gut be fixed by improving microbiome through diet and exercise?
Absolutely, yeah. So that was one of the big things is they saw that the bad microbiome balance was increasing inflammation along the lining of the small and the large intestine. And there was impacting the tight junctions, so the cell-to-cell junctions. So it was letting more stuff pass out of the intestines into the basically into the blood and the lymph than should happen. And so ideally you have this really great tight junction in your cells in the small intestine, and you want to, I'm trying to find it, you want to keep it as controlled as possible. But what they found with people that had the unhealthy microbiome is that they couldn't, it was like leaky. And so they were getting more bacteria in the, here, let me, try to share the screen. Again, this isn't mine, so we're going to do our best here. Okay, so you see this here. So this right here, these immune cells, this tight junction between the cells of the lining of the small intestine specifically, it allows for a larger gap. And so there's less regulation of what can and cannot pass into and out of the intestines. And so what can and cannot pass into and out of the blood and the lymph. And so what you want is you want to have a really good tight junction. And so you're controlling and regulating how much is coming in and out here. But if you don't have that, because the microbiome here is off, it's going to disrupt that barrier. So yeah, absolutely 100% increase the intestinal permeability. So a dysbiota, so an imbalance in the microbiome, is going to increase blood-brain barrier permeability, which is not good. You don't want that. You want to keep the bad stuff out and the good stuff in. So the brain, for sure. Also the intestines. You don't want everything that you eat to go into your body until it's ready to go into your body. And so that is improved with more of the plant fibers, and then decrease mucus production and viscosity. So the mucus is supposed to be a really good protective mechanism, and that is decreased. And so it just causes more damage and inflammation and swelling and build up really along the lining, the internal lining of the small intestine and the large intestine than should be there. So yeah, it absolutely can be benefited by changing your diet. Purposefully, mindfully changing your diet.
Cool. Okay, there's a few questions here I wanted to get back to. Okay, one about fibromyalgia. So I have fibromyalgia, not me, but the person asking this question, and have used an herbalist in the past. Do you recommend this approach along with an English garden diet and exercise? And then kind of related to that, there's another question about holistic medicine and if that addresses, and it's sort of based on kind of targeting the microbiome.
I believe in everything. I believe in everything that you feel brings value. And so if working with an herbalist to you brings confidence in your decisions and it makes you feel empowered in your health, work with an herbalist. If ideally you can work with an herbalist. I would never say don't. Ideally, you're doing it through diet and lifestyle changes, because that's what's going to, chronic changes are going to cause chronic changes. Taking a supplement once a day might not bring the same degree of change and improvement in symptomology as making like your 3 meals a day be high quality meals. So and I have the saying, you can't out supplement a bad diet. So you can't eat McDonald's 3 times a day and take a multivitamin and expect to be the pinnacle of health. It doesn't work like that. If you have to have sustainable methods to have sustainable results. So if you have an awesome diet that you feel is very balanced, it doesn't have to, I hate clean. It doesn't have to be clean. It doesn't have to be free of bad foods. There's no bad foods. Food is food. Food is awesome. Food is fuel. If you want to eat Cheetos, eat the bag of Cheetos. But if you feel like you have a very good diet and you're not getting the relief of symptoms that you feel you should have, or the energy that you should have, one, get a blood test, make sure there's not something else going on, go see a professional. And then you can work with an herbalist and see if maybe there's something in addition to eating all these wonderful greens and colors and things like that you could take in addition that would also help. But I wouldn't see a professional or a naturopath or a wellness or a holistic practitioner and not be addressing the other aspects of your life, your daily activity. So making sure that you're not sedentary, that you're walking at least, please, for the love of everything, at least 5,000 steps a day. And I know that seems like a lot for some people, and it seems like not a lot for other people, but really 5,000 is like the low bar for acceptable. 7,500 is really like the threshold between, if you can get up to 7,500, your risk for cardiovascular disease plummets dramatically. And really everything above 7,500 is really just like extra credit. So they say 10,000 steps a day, but for some people that's not sustainable. So I say 7,500 because that's realistic, but it's still hard. It's still like a stretch goal. So yeah, you can't out supplement a bad diet, but if you feel like you're not getting enough from your diet, absolutely. Do you?
One other question kind of related to, I guess, different treatment approaches. So Garrett asks, you kind of touched base on it, but my question is that I was under the impression DOs take a more holistic approach to medicine than an MD. Do they actually take a more holistic approach by doing herbal medicine and stuff? Question mark.
They don't do herbal medicine. They still do prescription medications, but they have a little bit more in their curriculum about holistic wellness and other non-traditional forms of medicine. So they have a little bit of introduction to Eastern medicine and like traditional Chinese medicine and Ayurveda and things like that, but they don't practice it. They're still like medical practitioners. They still do surgeries and they work in hospitals and they have clinics and they prescribe medications and things like that. But they're a little bit more likely to say, let's also work with your diet, more so than an MD. Not that an MD doesn't know, but their education is a little bit different. So, because I have a cousin who's a DO and I have friends that I work with MDs. I work with MDs and DOs, but I know both. And the focus of their curriculum in school is a little bit different. But once they do clinicals and internships and residencies and all that kind of stuff, it's in the same places. They're working in the same clinics, in the same hospitals, with the same patients, doing the same surgeries or interventions and things like that. The DOs might just be a little bit more inclined to also recommend non-pharmaceuticals, non-surgical interventions before. But they're not like weirdo hippie dippies. They're medical doctors. They just have a little bit more expansion in their curriculum.
Cool, great answer. And Isaiah asked, where to go? Do we find microbiome diversity based on ethnicity? So the ethnic differences, I guess, in microbiome.
It's what you eat. So they found with infants that, so how you're born impacts your microbiome substantially. So if you're born through the vaginal canal, you get the microbiome of your mother's vaginal canal, which is great. If you're born C-section, it's completely different. You only get the microbiome of the skin. And so what they found is that they can supplement though. They can do a swab of the inside of the vagina and they can rub it on the child's, like the infant's face when it's first born, and it'll get that bacteria and it'll be in their biome almost as if they were born vaginally. So they'll have those protective benefits of that microbiome. And the same thing with food. So if you're in an environment where there isn't a diversity of food choices, you can impact that by increasing the diversity in your diet. So culturally and just regionally, sometimes you don't have that in your, like if you live on an island and you only have 4 fruits and you only have 6 different vegetables that you can choose from, then you don't have the ability maybe to have that diversity. I don't know that it's so much cultural or genetic as it is environmental. So they found that environmental changes in your lifestyle, in your diet, in your socialization, what you're around, impacts your gut biome more so than what you're inherently like born with. So your environment is more formative than really just like what your last name is.
Awesome. One more question, and then I've got a few people that are looking for a book recommendation. The last question here that I see is, what does the category of processed meats include?
So processed meats is like anything, so deli meat, salami, pastrami, sausages, anything where it's not cut off as it walks by, basically, or like snatched from the stream. If they do anything to repackage it, like ground beef
too, right? Like,
yeah, like a steak. Like if you just have like a sirloin steak, that's just like you cut it off as it walks by and you slap it on a grill. That's unprocessed. But sometimes when they do like ground beef, they'll add things to it that might make it a little bit less healthy than just a steak, or chicken is good, and turkey is good if you can get it in just like a whole cut, even the leg, the fat in like a chicken leg, like a drumstick or a turkey leg, that's a higher fat in the meat. That fat is still more protective and beneficial than having the processed version of that. So if they take all that meat off and they process it into like a sausage, Frank, and you're like, turkey sausage, it's better for you than beef sausage. Well, it's not really though. So ideally you have it as close to nature as possible. And I'm a big proponent of protein, having enough protein in your diet. That is like what I preach for all my students. I'm like, don't be protein deficient, whatever you do, your body needs it, it can't store it. So please eat protein.
Awesome. And then any book recommendation? I had a few people ask for book recommendation. Melissa will.
I know. I don't. The microbiome diet is good. Tim, I referenced his talk on one of my slides. He gave a really good presentation at the British Academy, the Royal Academy. I think his is the microbiome diet. Honestly, I don't read diet books. I don't read those kinds of things because I feel that gives you perhaps a negative association with food, and that it makes it become restrictive. Like I have to eat like this or I'm going to die, or my microbiome isn't going to be diverse. I don't ever put myself into that feeling of like potential guilt or shame about what I'm eating or not eating. And sometimes books can indoctrinate you into that religion of how you should be eating. I don't feel like there is a should or a shouldn't eating, because then you're going to associate, you can have a negative association with food. And like diet culture, it can bring negative responses to food and lifestyle changes. And me personally, I just feel like if you want to make the change because you feel like it's going to make you feel better. If you want the education behind it to help you make that decision, great. But sometimes a book is just so much context of why you should only eat like this. If you don't, you're going to die and you're probably a bad human, that it could spoil you for seeing other ideologies behind what a healthy lifestyle is, what a healthy nutrition is. So the last slide that I ended with, really just like walk around the produce section and put it in your cart like that. That's it. Like just put it in your cart, whatever you see. There's tons of healthy fats, eat them. They're great. Coconut stuff, avocado, flax, olive, sesame, walnut oils, tons of herbs and spices. Make your food delicious and awesome. And I feel like you'll be better off than if you try to ascribe to like one type of diet, because then you go off that diet and you feel like a failure, or it can bring in negative feelings of worth, like, oh, I can't even stay on this diet. So do you. You'll feel better if there's less pressure.
Well, thank you so much, Kate. That was a really great presentation, and I know everybody really enjoyed getting their questions answered. So thank you again. Big round of applause. I'm sure everybody is applauding in their bedroom or their office, wherever they are. Yeah, thanks again. Just for everybody's reference, we have recorded this, and we'll try to get a link out so that people can watch it later. And we will, and also look out for future FAC forums in the coming months. So thanks again, Kate.
Thank you. Bye, guys.